Listening up, attention please. If you guys want, you can open up your device already and you can write up your answers in your documents as well. But this is on Google Classroom, so you can always copy and paste it later. What I want to do is the second teacher demo, so that way you guys can kind of see from the beginning how to do that process. So the first demo we looked at on Tuesday, and I still have the test tubes here. One of the things that I said in those test tubes was that the precipitate was going to sink to the bottom and you're going to have the remaining solution on the top, and we can see what color it is. I'll put it on the document camera as well so you guys can see what I mean. So you see how it settled out? It's precipitated. So do kind of keep that in mind. With some of those reactions, you just need a little bit of time just to watch the precipitate sink and confirm the color of the solution. So do keep that in mind. When you are stating your observations, you are stating it both in what's solid and what's in the liquid. Can we put away the phones, please? I am literally going through an example. All right, keep going. Okay, so second example that we are doing, we are taking copper sulfate. So copper sulfate is this solution here. And we're going to make observations. So you need to do observations for the achieved. So what color is this? Blue. All right. What state is it in? Liquid. So I'm mixing two liquids together, which is a real key characteristic of precipitation reactions. Right, the second one I'm getting is my sodium hydroxide. So sodium hydroxide is this guy here. Clear. Clear. But we're going to use a better word than clear because this here is clear. I can see through it. Not transparent. Colorless. Don't use the word clear. Use the word colorless. It's a better descriptive factor. Colorless. Again, I'm writing this in red because it's an achieved requirement. You need this to pass. All right, yeah. All right, state. Liquid, solid, liquid, gas. We are thinking liquid. All right, now I'm going to get my test tube. I'm going to mix it together. I'll do it under the document camera so you guys can see it a bit better. And I'm going to put a white piece of paper underneath it so you can also see it. So here is my blue liquid. That's the copper sulfate. Put away the phone. All right, let me just make sure that focuses. Focus. There we go. All right, here's my sodium hydroxide. Whoa, we saw something form. It's very, very clumpy. I'm going to add more sodium hydroxide just to make sure that all of that copper sulfate has reacted. So you see? We have a blue solid, don't we? All right, so under my observations, we are writing down here, a blue precipitate is formed. Red, blue, precipitate, and I'm happy if you guys want to write PPT because precipitate is a long word. And what color is the solution? Blue. Look at it under the thing again. Is the solution colored?
Yes.
No, the solution itself is not colored. So, in a colorless solution. All right. Next thing I need to do then is I need to figure out what my products are. Do you guys want me to do this on paper so you can kind of see the working there? Or do you want me just to type it? Happy with me typing it? All right. So, things to keep in mind when we are looking at the products. We are thinking about copper sulfate is one reactant and sodium hydroxide is the other reactant. I'm going to swap around my cation to figure out my product. So if I had copper sulfate and I want to take the copper and swap it over here, now I have copper hydroxide. And then what's the other one? Sodium sulfate. We good? All right, I might zoom it up so you guys can see it a little bit better. There we go. Okay, so let's change that now again to red because we're doing the achieve stuff. So achieve requirement is just identifying this type of reaction. All these reactions that we are doing this week and next week are going to be those exchange reactions. If you call them precipitate reactions, I will also accept it. So this is an exchange reaction. Cool? That's all you need for it achieved. If we are trying to get this up to a merit, I need to add my reasoning. A very good way to get you guys up from an achieve level answer to a merit level answer is you use the word because. I'm going to underline that because that is going to be such an important word this year, because. Because now you're starting to explain it. And thus getting to the merit level. So, in this case, because the copper ion from the copper sulfate has swapped with the sodium ion from the sodium hydroxide, forming copper hydroxide and sodium sulfate. This is an exchange reaction. I'll zoom it up a little bit just to make it a little easier for you guys to see. So for the merit, we are just defining the Y. So I'm basically just giving a definition for what an exchange reaction is. And with that definition, I'm being specific and tying it back to the example at hand. Yeah? You need to tie it back to your specific example. Are we okay with that? Yes. Can I keep going? Yes. John, is that a question?
Just a grammar question.
Yeah.
It says, for sulfate, it's spelled S-U-L-P-H.
Yeah, so both spellings are accepted. One's the English, one's the British.
All right.
I don't know which one's which from memory. This is probably the Americans.
Yeah.
Knowing me. I will accept both.
Yeah.
Don't stress. All right. We good?
Yeah.
Okay. Next thing for the merit, for my achieved is I need to figure out the precipitate that is formed. For the achieved, we just need to figure out what it is. For the merit, we need to explain why. So, we had two possible products here. I'm going to look at my solubility rules to figure out which of those two products is my precipitate. So, there were two things there. The first thing that we had was the hydroxide. We had copper hydroxide. It says here that all hydroxides are insoluble with the exception of potassium and sodium. So in this case, is copper one of those two things? No. So this is very likely my precipitate. The other thing I'm checking is my sulfates. Sulfates, it says all sulfates are soluble except barium, lead, and calcium. I had sodium sulfate. Should that be soluble? Yes. Yeah. Yes, because all sulfates are soluble. So we have identified what the precipitate is. So over here, we would write down, let me just change it to red. Zoom back out. All right. Copper hydroxide is the blue precipitate. It also makes sense because the copper sulfate was a blue solution, so I'm not surprised that the precipitate is also blue. My battery's running low. I need to plug it in. All right. Now we need to justify. So let me change this guy to blue. And we're using my favorite word in the whole wide world. Because, underline, because. If you don't use the word because, I'm going to be sad. Right. Why? What did we discover? John.
All hydroxides are insoluble.
Yeah.
Except for potassium and sodium, copper.
Yeah. So all hydroxides are insoluble except sodium and sodium hydroxide and potassium hydroxide. Since this is not one of those, the copper hydroxide is the precipitate, or is insoluble. And you can add some more layers if you want, and thus the PPT. If you want more layers, just to be clear that that's my reasoning. This is copper is not one of those. There you go. Cool? All right. This will be on Google Classroom if you need it. If you missed anything. All right. Keep going. So I'm mindful, I want to give you guys study time. What? All right, equations? All right, so that's the first half. Then we're going to scroll down. So this is the 1, 2, 3, 4 practice problems that I have for you guys. So when you're thinking about what do you want to get done for the remainder of this lesson, once I'm done with the notes, you can work on these. You can work on old homework. I'm not fussed. All right, here are my equations. So we'll start over here. We're mindful, what do we need to do for the achieved? All right. Now, for the achieved, nice and easy, we are taking the information that we had at the start of our sheet, and we're just copying it down. So you're writing your reactants, copper sulfate plus sodium hydroxide. It's important that we're using the plus sign because that's how we communicate in chemistry. We do the arrow, not equal signs, not math. Arrow. Oh, how did I do that? I did dash, dash, and then the greater than symbol. All right, and then I go copper hydroxide plus sodium sulfate. Thank you. All right. Ooh, that's a typo. Greater. All right, now we got to move to our symbols. This is the harder part. Let me move that to blue. All right. So, symbolic equation is we take this information here and we're going to translate it into our symbols. I will give you guys some worksheets tomorrow when I'm away. If you are struggling with this, you can practice this, okay? All right, copper, Cu, sulfate, So, and then now we need to do a subscript. We don't want to just type 4 because that's not the proper chemistry language. We need a small 4. The way we make the small 4 is that we're going to hit the control key and the comma key on our computer, and that's going to bring it down to make our tiny 4. Whoopsie. Our tiny 4. Whoopsie. Okay, control key, comma key, now I get a tiny 4.
Oh.
And if I want to undo that, and for my next bit, not have everything typed really tiny, control key, comma key, now we're back to normal. Okay? All right, so that's copper sulfate. The next thing I need to put down is my sodium hydroxide, which is NaOH. And then the last thing is I need to translate those two products into my formulas. So copper would be Cu, Hydroxide is OH. I need 2 of them to balance that charge, so I'm putting things in parentheses and making my little 2. Hydroxide only has a -1 charge. Copper has a +2 charge. I need 2 hydroxides to balance the charge. Don't worry, if you're struggling with that, I will give you some worksheets on that tomorrow. All right, plus sodium sulfate. So Na, small number, 2. Because remember, sodium has a +1 charge, sulfate, -2. So I need 2 sodiums to balance the -2 charge. SO4. That's what that guy looks like.
Second one is always capital.
Second one's always capital. You have the right point though, Savannah. Whenever we have a capital letter, that shows a new element. So you have to be really careful with your writing, and I will mark you down on it. If you write NaOH like that, I won't mark it as correct. Because right now you're saying nitrogen. I don't think we have an element that starts with A, but like that's the idea.
Argon.
Argon? I thought argon was AR. Anyway, that's my point. All right. If we want to be lazy, we can just copy and paste over this equation for when we balance it. Because why bother doing all that work again? Change the color to green. Now, you don't need to do this changing of colors when you're writing your answers. I'm just doing that so you guys are aware of achieve merit and excellence. Keep in mind, this is not the only thing you need to do for excellence. There's one more layer, which is the compare and contrast between the 2 different types of reactions. But I won't be able to even give you excellence if you don't have the equations right. Okay? All right. Now I need to balance it. So I see on this side of the equation, I have 2 hydroxides and I have 2 sodiums. Remember, at this point, we can only add coefficients. We can't change the formulae number. So I'm just going to put a 2 in front of here. So that way, I now have 2 sodiums and 2 hydroxides.
2.
Just a 2 in front.
Also, you can make 2 hydroxides.
2 hydroxides and 2 sodiums. Again, tomorrow when I'm away, I will have various worksheets. You guys can do practice on formulas. You can do practice on equations. Cool? All right, that's everything for me.
Wait, that is for balancing.
That's it for balancing it. It's already balanced. The sulfate's 1 and 1. The copper's 1 and 1.
Oh, I see.
Yeah? Don't stick numbers in there just for the sake of sticking numbers. All right? We're not accountants. All right. Cool. You guys have the rest of the period to get work done. What time does this session end? 30. Not that I don't believe you. All right, 10:30. So you guys have about 40 minutes. So think about, hopefully your goal will still work. If it doesn't work, adjust it, maybe take something off. I'll bring out the chemicals. So if you guys haven't finished the practicals, definitely do that now, because tomorrow with the reliever, I can't leave the chemicals with them, okay? No, you should be using them to study. All right, I hear the negotiation going on. I would want you to work because I'm not going to be here tomorrow. So it's really important that you guys ask me your questions now because your assessment's starting next week. I wouldn't suggest using your 40 minutes.